Test, test. You all hear me? Great, because I like to move around. And I may even be on the floor because I'd rather you look up here than look at me. But you probably wouldn't want to look at me anyhow, so maybe it doesn't matter. So anyhow, like I said, I'm here at Penn State. I hope you all have enjoyed your visit to State College, and exciting to see what folks like the Game Commission are doing around here. I've only been here about a year, so I'm learning a lot, and I'm really excited about what's going on in the state of Pennsylvania, and I'm really getting to know and enjoy this area. So hopefully this talk is a nice follow-up to what Heather was talking about, particularly in the last part of her presentation, because I'm going to present some of the work that we've looked at trying to get at some of the, a couple of the mechanisms that were hypothesized in this mesophycation issue, and particularly focusing on moisture dynamics and flammability in leaf litter. And it was nice to see some of the work that Heather's doing, showing some of the stuff in the field, because I'll be presenting a lot of our lab work where we were trying to look at a lot of this stuff under really controlled experiments. So, congratulations to Mark Abrams this morning receiving an award, and the others that received awards for the work that they've been doing in fire, particularly in oaks in the east. And for those of you that know or are familiar with mesophycation literature, would recognize this 2008 paper that Mark and Greg Nowacki had published, kind of coining the term mesophycation, and this kind of kicked off our thoughts about this mesophycation issue and what's happening. And so, two of the mechanisms that they propose that I want to talk about today are, one, this idea that these fire-sensitive, shade-tolerant mesophytic species that established in these once fire-prone, more open oak woodlands end up closing the canopy and sheltering the structure, essentially causing cooler, damper forest floor conditions. Okay? And so essentially the idea of shading the forest floor, so the mechanism of shade. Okay? Another one they discussed about is the role that leaf litter composition may actually have. Okay, so they're discussing this hypothesis Heather is getting at with some of her research, that the leaf litter itself may be dampening fire behavior through increasing moisture retention, and that they actually don't burn as well. And so we kind of started doing some work to try and get at some of these mechanisms with controlled laboratory experiments. So when we look at the impacts that sun has on forest floor litter and moisture dynamics, it's pretty compelling. People that burn understand that the sun makes a difference in flammability. Okay, it heats up the forest floor litter and creates impacts, right? When we look at it, it's pretty interesting when we look at shaded versus unshaded fuels. And up on the top there you can see that open square at 1300 is unshaded oak litter. This is post oak and southern red. And then the open circles are unshaded longleaf pine litter. Three are pretty flammable species, by the way. So you can see this is the effect that the sun has on leaf litter temperatures. Okay? We see that unshaded fuels, particularly in the oak, are upwards around an average of 45 degrees Celsius, almost 115 degrees Fahrenheit. Okay? Some of our maximums we were getting was about 50 degrees Celsius. So that's a pretty substantial increase in leaf litter temperature as a result of solar radiation. Okay, so we're seeing that on the ground in experiments where we're looking at litter temperatures with infrared cameras. And what we find is how that's reflected in moisture dynamics. Okay? So if the surface of these fuels are much hotter, there's a boundary layer conditions that's created that exacerbates the vapor pressure deficit and rapidly draws the moisture out. Okay? So when we look at this over time, in this graph you can see going from 900 in the morning to 1300, this is down in Florida, that even in the beginning, on the upper left there, we see differences in shaded versus unshaded southern red oak litter. Okay, even at 9 in the morning where there's a little bit of difference in fuel temperature. Okay, the shaded litter is already a little wetter than the unshaded litter. Okay, so you have shaded and unshaded southern red oak there. But also what's interesting, you look at over time what's happening throughout the day, is here's your pine litter down there in the bottom. Okay, and we're thinking a lot about oaks in this conference. And when I think about the dynamics of oak litter versus some other litter, look at what that oak litter moisture is in the morning versus pine litter. Okay, sometimes in the South you hear folks that aren't really interested in oaks in their landscape will say, well, we can't really get oak litter to burn. Okay, well, if this is about when you're doing your test fire, how's that oak litter going to burn versus that pine litter earlier in the day? Okay, but if you look at over time how reactive this oak litter is, you can see it's drawing pretty rapidly. Okay, you still see the impact that the sun has over time, but getting about noon, these differences are starting to fade away between oak and pine litter, and the oak litter is getting pretty flammable. And actually, if you look at 1300, while the shaded oak litter here is actually the wettest of all of these, the unshaded oak litter is the driest of all this litter. Okay, and they're pretty close. Okay, but it's interesting thinking about how the composition of the fuels matter when we're looking at fire behavior on the ground. Okay, and looking how that looks over time from our early, test fire to as we're burning throughout the day, and that these different fuels are reacting in unique ways. Okay, so we kind of scale up and look at the actual flammability. We've done experiments where we kind of mimic the sun with infrared lamps and then dry them out and do these experimental burns to say, well, okay, we know that the increase in temperature of the sun is causing drastic differences in how rapidly moisture draws out. How does this look at flammability? Okay, so maybe this is a little complicated on the right. I don't think so. We essentially have flammability on the y-axis. Okay, we kind of pulled together different metrics there. And then we have drying time on the bottom there. So this is in a lab. We soak up this litter and then we let it dry. Okay, so you kind of think about this as maybe early in the day, early in the morning on the left side, and then it's drying out for 24 hours. Okay, and in this particular graph, the dark circles and triangles are the heated litter. Okay, so these are the litter that we're mimicking the sun, while the open circles and the open triangles are those that would essentially be shaded because they're not getting this infrared exposure. Okay, and what we see throughout the day is that essentially the shaded litter takes a lot longer to get as flammable as a litter that's exposed to the sun. Okay, and if we kind of look at the top here, if you look at on the upper left, the litter that's exposed to these lamps are essentially mimicking the sun is getting really flammable very quickly. Okay, so if you compare that to the shaded litter, it can take almost upwards of 20 hours for this litter to become, it's particularly in heavier, denser litter, to become as flammable as the litter that was exposed to the sun in only about 4 or less hours. Okay, so really highlighting here, in kind of a controlled way, the impact that infrared radiation is having on flammability, and in concert to that, what the impact of shading of fuels has on litter flammability. And this is largely, in these experiments, we were able to kind of take apart the impact that leaf litter temperature had itself versus moisture dynamics, and largely this impact on flammability is occurring because of that rapid impact on litter drying, which is kind of neat. Okay, so just from our laboratory experiments, kind of looking at, okay, that whole idea of how shade is going to impact forest floor moisture dynamics and flammability, we certainly see that in really controlled ways. Okay, and we see how much of an impact that has. Okay, and all of you that burn kind of see that and notice that as you're burning, whether you're burning in a sheltered stand or burning in an open stand, or as the sun's coming out later in the day, you're seeing that. Okay, we're getting a little more nuanced look at it. But what about when we look across species composition? Okay, and Heather talked about this a little bit. Okay, this is some of the work that we did looking at moisture dynamics in litter across a suite of species that include several oaks, but also some mesophytes or mesophytic species that are kind of classically implicated as mesophytic species. And so when we look at moisture dynamics, there's quite a bit of variability across species. And it's interesting that they cluster out in ways that are kind of fascinating to us. So if we look at it this way, essentially on the right hand we have initial moisture content on the bottom. Okay, so that's how much moisture the litter of these species is soaking up. Okay, and then on that y-axis is drying response, which is essentially time lags. So if you're familiar with time lags, we're getting the time lags on these fuels. Okay, so on the lower left, we have fairly low moisture retention, which means these fuels don't take up a lot of moisture and they dry rapidly. Okay, in the upper right, we have high moisture retention. Okay, they soak up a lot more moisture and they dry rapidly. Okay, so you can see in the lower left, our oaks are basically all in these kind of two clusters here. Okay, particularly this cluster on the lower left, where a lot of our oaks that we know are fire tolerant and persist in these fire-prone environments, particularly in the southeast, really retain low moisture. They don't soak up very much moisture, and they dry really rapidly. Okay, here this little cluster on the top here, we have Quercus nigra virginiana hemispherica. Because for those of you who aren't familiar with the South, okay, not all oaks are the same. Okay, this cluster is not taking on as very much moisture, but they're actually slower to dry than the little cluster below it. Okay, these are the oaks in the South that are implicated as actually mesophytes. Okay, we know that they come in to these longleaf pine ecosystems, and they're kind of invading with fire exclusion. They're thin bark. They actually don't have a lot of these fire-tolerant traits that most of the oaks up here have. So it's interesting in the South because there's a lot more variability in the way that oaks fit within these different fire regimes. So it's interesting for us to even see in this capacity. You move to the right, you can see beech and tulip poplar there. Okay, they're taking on a lot more moisture. Okay, so these are kind of some mesophytes that would be of interest. And then we see our freak here on the upper right, right? Red maple. Okay, it's taking on the most moisture, and it's the slowest to lose that moisture. Okay, so out of all these suite of 17 species, red maple is really standing out. It's having the potential solely of the litter itself to be able to retain moisture. Besides all the other impacts that it has on canopy structure and some of the really cool stuff that Heather's showing on stem flow, okay, that it has this added impact. Okay, and so how does this look in the field? We've done a little bit of trying to tackle this and see what this kind of looks when we're looking at the operational or stand level. Okay, and so we looked at some sites at Strawberry Plains Audubon Center in North Mississippi with some sites that Steve Brewer from Old Miss has been working on for quite a while, doing some really good oak hickory restoration. So we had some opportunity to go in and do some sampling over 24-hour periods, both at the base of trees on the left and out in the open, kind of look at in sites where Steve had actually thinned out mesophytes, okay, girdled them and taken them away, and then been burning about every 2 years, I believe, for 10 or more years, okay? So that would be the thinned and burned stance. Essentially, the mesophytes have been taken away. Their litter is not being incorporated in the forest floor. The stands are a little bit more open, and they've been repeatedly burning, okay? And we can see in this sampling here, this is over 1 day, that consistently the litter, both at the base of the trees and out in the open, are drier in those thinned and burned stands versus controlled or even stands that had been burned, but there are still mesophytes in there, okay? What's interesting to me on this one is if you look at when the sampling was, this was December, okay? So in this particular sample, we've kind of taken away this whole shading impact, okay? Because even there, it's deciduous, the leaves are gone, okay? So this might be telling us that leaf litter composition is really driving some of these differences. There may be some other stuff going on, but it's kind of interesting. That's why I wanted to point out this December sampling issue. So we're seeing this a bit in the field. And it looks like Heather's seeing this in some further work that her and her lab are doing. Okay, so when we pull all this together, if we pull together composition, moisture, and flammability, okay, we did some laboratory experiments, and I don't know if you remember, these are quite similar to some of the mixtures that Heather did. It was really cool to see that she was finding some of these same results in the field. That here we have flammability on the x-axis again, okay, and then on the y-axis, sorry. And then on the bottom, on the x-axis, as you go from the left to the right, these are mixed litter beds. So we're incorporating mesophytic litter into oak litter, okay? So on the left, it's all oak litter. When you go over to the right, it's 100% mesophytic litter. In between, there's a percentage, okay? And what we did is we do this over time. We saturate them and allow them to dry, and then we burn them at 12 hours, we burn them at 24 hours, and then we burn them at equilibrium moisture content, so they're all basically dry. And we see a significant dampening effect that these mesophytes have on flammability in all of those scenarios, okay? Of course, after 12 and 24 hours of drying, that impact that it has on moisture dynamics is playing a large role in dampening flammability. But even up at equilibrium moisture content, essentially all the litter is about 7% in these lab experiments, and we still see a dampening effect that mesophytes have solely because of the impacts that they have essentially on the fuel bed characteristics. Okay? I think all of this is particularly important in the east because unlike the west, out here we don't have these long, seasonal dry periods like you do in Mediterranean climates. Okay? So in humid environments out here, particularly even in the, maybe more so even in the south, but also where there's a lot of punctuated rain, burn windows are a real concern, okay? And so these kind of differences that fuels may have may be really important in addressing and thinking about these burn windows more than out west, where like maybe the impacts on moisture dynamics aren't that critical because guess what? Everything's 3% moisture content, right? Okay? So this, I think, plays a significant role in trying to burn in the east. Okay? If we kind of go back to our fire environment triangle, okay, we know that weather is an important factor in us in having the burn windows that we can then burn under, right? But fuels can make a real difference, okay? And whether or not that fuel is available to burn to get the kind of fire behavior that we want. And of course, we have, some of these coarse tools that we use to give us some idea of what fire behavior may be, okay? But I think it's important just to understand and be focusing on some of the variability that we might have, not only on forest structure, and we have in some of these tools, Appendix B in the handbook, there's shaded versus unshaded, but we're certainly not looking at differences in composition and litter and how that might happen, okay? And I remember on the first burn I was on out here, actually up at Game Lands 33, where we all were yesterday, we were burning a bunch of oak. And I remember talking to Ben, and after the fact, because we were talking about, the calculations of pig. Where's Ben? Is Ben in the room? Maybe not. Maybe he's out. I think our calculations of pig were something like 30% on that day, okay? And so this was not this spring, but the following spring up at Game Lands 33 in that long ridge. How many of you were on that burn? Anybody? It seemed like there was quite a few game commission. Anyway, basically you're fighting spotting the entire day, okay? Pig was fairly low, but it was spotting along both sides of the lines, and it was constantly, this oak litter was like, spotting everywhere, okay? So just thinking about things like that, shading and composition actually matter, okay? And so anyway, the way I like to think about it, of course, is that, when we're managing things like forest structure and forest composition, we're also managing fuels, right? Okay? So in this mesophication situation, we might be managing to remove mesophytes to open up structure and alter composition, but obviously we're impacting fuels too. Not just the fuels that are on the ground, the litter composition, but the interactions that it has with its environment, right? Opening up a stand and removing mesophytes is not only going to open it up to more forest floor solar heating, but also is going to have a less proportion of these mesophytic species that are a little more difficult to burn. So just kind of be thinking about that kind of stuff. Of course, managing fuels is managing fire behavior, right? Okay? And ultimately, managing fire behavior is managing the fire effects that we want to see on the ground, okay? Not only the immediate, first order effects, but what are the effects of the vegetation response following that? And then that leads to the kind of fire behavior that we get subsequently when we're coming back to do repeated burns. And so with this, I will go ahead and say thank you.